Now for problem 1, as what you can see, the graph of g of x equals to log of x with a base of 5 shifts the graph of f of x is equals to log of x plus 2 with a base of 5 2 units upward. Next, for the asymptote, as we all know, an asymptote is a line that a curve approaches but never touches. So for problem 1, we have our vertical asymptote at y-axis, or x is equivalent to 0. Now for our x and y-intercept, we only have our x-intercepts and also our zeros. And now for the domain, in order to find the domain, we just have to find where the function is defined. Okay, so for our domain, we have 0 and positive infinity. And as for our range, it is a constant negative infinity and positive infinity.
Okay, so for number 2, we are given with the function of f of x equals log base 4 of the quantity x plus 3. So we have its graph and its table of values. So by using this, we can now identify the characteristics of its graph. Zeros, x equals negative 2 for the horizontal asymptote is none. Vertical asymptote is x equals negative 3. X-intercept, negative 2, 0, y-intercept, 0, log base 4 of 3, or like we don't really know the exact location for this. And for the domain, negative 3 to positive infinity, and range, which is always constant, negative infinity to positive infinity. So for the transformation of this graph, the graph of the function f of x equals log base 4 of the quantity x plus 3 shifts the graph of the parent function f of x equals log base 4 of x 3 units to the left.
Now for problem 3, our graph of g of x is equivalent to log of x with a base of 5 reflects the graph of f of x equals to negative log of x with a base of 5 about the x-axis. Now for our asymptote, we have our vertical asymptote, which is at the y-axis, or x is equivalent to 0. Next, we will have our intercepts, which is our x-intercept found in here, which is x is equivalent to 1. Next is our zeros, which is x is equivalent to 1 also. Now for our domain and range, as we all know, domain is can be found by finding where the function is defined. Now for our domain, we have 0 and positive infinity, and our range, which is constant negative infinity and positive infinity.
Okay, so for number 4, we are given with the function of f of x equals log base 4 of negative x. So we have its graph and its table of values. Using this, we can identify the characteristics of its graph. So let us start with zeros, which is x equals negative 1, horizontal asymptote is none, vertical asymptote is at x equals 0, or simply the y-axis, x-intercept, negative 1, 0, and we don't have any y-intercept. For the domain, we have negative infinity to 0, and for the range, as always, negative infinity to positive infinity. For the transformation, the graph of the function f of x equals log base 4 of negative f. X reflects the graph of f of the parent function f of x equals log base 4 of x about the y-axis.
So the logarithmic function f of x equals 3 log base 5 of x, and its parent function is g of x equals log base 5 of x, given the table of values of logarithmic and parent function. And we can see that the graph of logarithmic function f of x equals 3 log base 5 of x, since the c is greater than 1, which is 3, it stretches the graph of parent function, which is g of x equals log base 5 of x. And its characteristic is the vertical asymptote is at y-axis, thus the vertical asymptote is x equals to 0, and its x-intercept is 1, 0, and its zeros is x equals 1, and its domain is 0 to positive infinity, and its range is still negative infinity to positive infinity.
Now for problem 6, the graph of g of x with an equivalent of log of x with a base of 8 shifts the graph of f of x is equals to negative log of x minus 3 with a base of 8 3 units downward and reflects about the x-axis. Next, we'll have our vertical asymptote, which is found at the y-axis, or x is equivalent to 0. Then, our function also has x-intercepts and 0 as what you have observed and seen in the graph. Next, we'll have our domain, which is 0 and positive infinity, and our range, which is constant negative infinity and positive infinity.
g of x is equals to 7 log base 3 of negative x. Its table of values will look like this, and based on that table of values, its graph will look like this, where the vertical asymptote is x equals 0 and the x-intercept is equals to negative 1. The domain and then the range. If we will compare it to its parent function, which is f of x, is equals to log base 3 of negative x, we will have this as the graph. We will describe it as the graph of g of x is equals to 7 log base 3 of negative x. X stretches the graph of f of x is equals log base 3 of negative x. It stretches because the c here, which is 7, is greater than 0. Number 8, g of x is equals to negative 9 plus log base 8 of x. Its table of values will look like this, and based on that table of values, its graph will look like this, where its vertical asymptote x is equals to 0. It has x-intercept and zeros, the domain, and then the range. If we will compare it to its parent function, which is f of x is equals to log base 8 of x, we will have this as their graph. And we will describe it as the graph of g of x equals negative 9 plus log base 8 of x shifts the graph of f of x is equals to log base 8 of x 9 units downward. It is 9 units downward because 9 here is negative and negative 9 is less than 1.
Okay, so for number 9, we are given with the function of f of x equals log base 2 of the quantity x plus 1. So we have its graph and its table of values. So from this, we can identify its characteristics. So we have the zeros, x equals 0. Then horizontal asymptote, we have none. And for the vertical asymptote, we have x equals negative 1. For the x-intercept, as we can see from the graph, we have it on 0, 0, and so with its y-intercept. For the domain, we have negative 1 to positive infinity, and the range, as always, negative infinity to positive infinity. For the transformation, the graph of the function of f of x equals log base 2 of the quantity x plus 1 shifts the graph of the parent function f of x equals log base 2 of x 1 unit to the left.
So number 10 is the logarithmic function is f of x equals 9 log base 5 of x, and its parent function is g of x equals log base 5 of x, given the table of values of logarithmic and parent function through GeoGebra. And the graph is, we can see that the graph of logarithmic function f of x equals 9 log base 5 of x stretches because the c, which is 9, is greater than 1. So it stretches the graph of parent function g of x equals log base 5 of x, and its characteristic is vertical asymptosis at y-axis, thus x equals to 0 and it passes through the point 1, 0. So x-intercept is 1, 0, and there is no y-intercept. And its zeros is x equals to 1, and the domain is 0 to positive infinity, and still the range is negative infinity to positive infinity.